Hello everyone. Okay, this section is 11.3. We're going to talk about perimeter and area of similar figures. So first let's talk about similar polygons and what we're looking for here with ratios. The side ratios between two figures, and I'm going to let my scale factor be a over b, a fraction. And so the side ratio is just that a over b. That's going to be, it's the scale factor. That's the ratio of the sides is also the scale factor. Now perimeter, since perimeter is a single unit, when I add up all the sides, I still get feet. If your sides are in feet, I add them all up and I still get feet. So then my perimeter ratio is still a over b, a to b. Okay, so perimeter ratio a to b. Now the area ratio, think of area as we know is a squared unit. If I have the area of a rectangle, it's length times width, so feet times feet if it's in feet. Area is a squared unit. And so to get the ratio of areas between two similar figures, we're going to square the scale factor. So we would take that scale factor or that side ratio and we're going to square it, and that will give us the area ratio. And then volume, the last one, is a cubed unit. And so to get the volume ratio between two similar figures, we would take the scale factor or side ratio and we will cube it to get the volume ratio. So let's look at this example. Triangle ABC is similar to, remember our symbol there, the little squiggle line in between, is similar to triangle DEF. And so for A, we want to find the ratio of perimeters between the two. So remember that the perimeter ratio here is the same as the side ratio, which is the scale factor between the two. So we're going to find two corresponding sides, and since we only have two measures, let's make sure that these two sides are corresponding. So BC is the second, third letter, and EF, second and third letter in the similar triangle, and so those are corresponding pieces. And so the ratio of perimeters between the two figures, figure 1 and figure 2, so BC is 8 over 12. Now, whenever you write a ratio, whenever you make them, remember that you have to reduce. So I can divide the top and the bottom by a factor of 4. So I can reduce this to 2 over 3. And so that would be the ratio of the perimeters of the two figures. Let's find the ratio of the areas. Let's write this one down. Ratio of perimeter. So on this one, we're going to find the ratio of the areas. So the area ratio, we take the perimeter ratio, which is also the scale factor, or the side ratio. That's all the scale, side ratio, perimeter is single units. And so we take that 2/3, and I'm going to square it. When I square that, I get the area ratio. Now remember, if I square a fraction, that means I have to square the top and square the bottom, because this is the same thing as 2/3 times 2/3, where I would multiply across the top and multiply across the bottom. So when I do that, I'm going to get 4, 2 squared is 4, and 3 squared is 9. And so that would be your area ratio. All right, next example. Perimeter of triangle ABC is 16 feet. So let's draw ourselves a triangle, A, B, and C. And the perimeter, I'll write that down here, is 16 feet. Okay, its area, write that down below also, is 64 feet. The perimeter of triangle DEF is 12 feet. I'll draw triangle DEF here. DEF, and its perimeter is 12 feet. Given that ABC and triangle DEF are similar, we're going to find the ratio of the area of ABC to the area of, and this should have a triangle in front of it, DEF. So first let's find the area ratio. I can't find the area just yet, can I? I'm going to be finding that here in a minute. The last part of the question says, then find the area of DEF. So what I'm going to use is ratios. And I'm going to start with the perimeter ratio. That's the only one where I have a number for each one. I have a number for the perimeter of the first figure and the perimeter of the second one. So I can set up the perimeter ratio. And the perimeter ratio is 16 over 12. Remember to reduce your fractions, so take a factor of 4 out, and I will be left with 4 over 3. So that is the perimeter ratio right there. Now, what it asked me to find is the area ratio. And so to find area ratio, so the ratio that the two areas are going to be in is going to be the square of the perimeter ratio. So we'll take the perimeter ratio, which is also the side ratio or the scale factor, and we square it. So the area ratio, to AR for short, is going to be 4 squared, which is 16, over 3 squared, 9. So now I can set up a ratio proportion to figure out what the area, the missing area is, this one of the second figure. So I'm going to take the area ratio, 16 over 9, and I'm going to set that equal to the actual areas. So since the 16 is on the top, that's the ABC triangle, I have to put the 64 ratio, the area of that triangle, on the top. And then 9 is the bottom figure. Excuse me. So we put the area that we're looking for on the bottom. And now I'm going to cross multiply. So I'm going to get 16a equals 9 times 64. And that is 576. And so the area of the DEF is going to be divide 16 on both sides. And when you divide 576 by 16, you get 36. And so that's the area right here of DEF. All right, here's a couple more examples. Now in this section 11.3, we're setting up what these area ratio and volume ratio looks like. This section we're working on area ratio, and then in the next section we'll show you how to do volume ratio. So let's look at this next example here. The ratio of the areas of two regular decagons is 20 to 36. So that's the area ratio. 20 over 36. Now remember, the first thing you want to do when you write a fraction is to reduce that fraction. And so this fraction is going to reduce to 5 over 9. I can take a factor of 4 out of the top and out of the bottom. So my area ratio is now 5 to 9. But what do we need to find? We want to find the ratio of the side lengths. So remember that area is a squared unit. And so this is already squared. Now, this is my squared area ratio. If I want to go back to the side ratio, then I have to take that scale, or that area ratio, and I have to take the square root of the top and the bottom. So the side ratio here would be the square root of 5. So we have to unsquare it. Some of my other students like to say unsquare it. And so the side ratio is going to be the square root of 5 over 3. And that would be the side ratio. Okay? Second example here, rectangles 1 and 2 are similar. The perimeter of rectangle 1 is 66 inches. Rectangle 2, we'll put a 1 in there. So rectangle 2 is 35 feet long, and 20 feet wide. And we're going to show the steps we'd use to find the ratio of the areas. Ratio of areas. So let's see what kind of ratio we can set up to begin with. I have the perimeter of rectangle 1, and given the measures, I can find the perimeter of rectangle 2. However, notice that perimeter 1 is in inches. And so for perimeter 2, I'm going to have to change the 20 feet and 35 feet. We've got to go to inches on that. So the 20 feet is 240 inches. And the 35 feet is 420 inches. And so those will be the figures that we're going to have to use. Now, we can add 240, and the other side here is 240. 420 on the top side, 420 on the bottom. And that will give me a perimeter of 1320. That's a 3. 1320. So the perimeter of the top one, the rectangle 1, perimeter of the bottom is 1320. And so I can set up a perimeter ratio. So my perimeter ratio is 66 over 1320. Now, if you put that into your calculator to reduce this, if you're not sure what that'll reduce to, and I don't really want to, you guys have calculators. So we're going to put 66 divided by 1320 into the calculator, hit math on the left-hand side, hit the math button, enter, enter, and that'll give you this fraction in lowest form. And that fraction in lowest terms, lowest form is 1 over 20. So that is the perimeter ratio, which is also the ratio of the sides. Okay, we want to find the, what are we looking for? We want to find the ratio of the areas, and then we're going to find the area of rectangle 1. So this is the perimeter ratio. Let's change colors here, and I'm going to go find the area ratio now. And the area ratio, remember that we square both. So the area ratio is going to be 1 squared, which is 1, over 20 squared, which is 400. That's the ratio that these two areas will be in. And so this one, I'll write this here, this is the area that we don't know. And we can find the area of the bottom one, can't we? 240 times 420, because we're going to be doing this in inches. And we'll get 100,800. All right, so that is the area of the bottom figure. So I can take the area ratio now, 1 over 400, and set it equal to the ratio of the actual figures, which is A, the one we don't know, figure 1. So it'll go on the top also, because we've been doing the ratio as the top figure over the bottom figure. So we have to keep doing that. Top figure on the top, and the bottom number area in inches on the bottom. Then we would cross multiply. A times 400 is going to equal 100,800. And I'm going to get, I'm going to kind of run out of room here. I'll do my best. 400A equals 100,800. Okay, divide by 400, and the area of that figure is going to be 252 inches. Now, if you wanted to convert back to feet, it doesn't tell you that you have to. If you wanted to convert back to feet, you would divide that number by 12. There's 12 inches in a foot, so we would divide that number by 12 and get 21 feet. And so that's the area. Okay, so let's make sure we understand these ratios, the area ratio and the volume ratio, and ask questions when you need to. See you next time.